Okay, I'm just going to go over one example today. So finding a particular solution. I'm not making it any harder. It's just how to find the constant, basically. So we need some boundary conditions. So given that x equals a half, when y equals 6, solve 1 minus x squared dy dx is equal to xy plus y. The other thing I wanted to say last lesson is don't be tempted to start adding and subtracting with these. You have to divide because you need it all kind of being multiplied by this dy dx. So just be a little bit mindful of that as well. So I'm going to pull y out as a factor. And then I need to clear y's to the left-hand side and x's to the right. So I can divide 3 by y, and I can divide 3 by 1 minus x squared. I don't know, 1 step or 2 steps, whatever you feel comfortable with. So dividing 3 by y, this is like multiplying by 1, so that's going to give me 1 over y dy dx is equal to x plus 1 over 1 minus x squared. And then always, if you have difference of 2 squares in a maths question, just think, if I factorise that, is that going to make my life easier? So as soon as you see difference of 2 squares, think about factorising. And to cancel down a fraction, you need to get it in factorised form anyway. So x plus 1 over 1 plus x 1 minus x, and then these are cancelling off. So 1 over y dy dx is equal to 1 over 1 minus x. So that's all looking a little bit more straightforward. I need to turn my board over. Next thing is to integrate both sides with respect to x, and then these dx's cancel on this one. And so the integral of 1 over y with respect to y is equal to the integral of 1 over 1 minus x with respect to x. Sorry, I seem to be slightly croaky today. Integrating this, I get ln y. This differentiates to minus 1. So ideally you would have this, but I need that to equal that, and so I need that negative in front because minus 1 times minus 1 gives you plus 1. So you end up with minus ln modulus of 1 minus x plus c. So generic plus c from both those integrations. And then we really need to pull up this power. So it's the same process as we went through before. You could substitute in at this stage. I would probably substitute in later to get your constant. Obviously, both methods will work. There's an embedded sort of modulus sign in that, plus c. And then raising both sides, so we do e to the power of both sides, gives you y equals e ln 1 minus x to the power minus 1 plus c. And then when you add, this is the same as multiplying. So you get e to the power c times. I'm just making it really clear what I'm doing. You probably don't need to necessarily write as many lines as this. E to the ln, they're inverses of each other. So this bit here is just 1 minus x to the power minus 1. And then we replace e to the power c with capital A. So y is equal to a, lots of 1 minus x to the power minus 1. Don't get too bogged down with this modulus. It'll all come out within the domain that you're given, so don't start overly worrying about that. You'll just get yourself into a tangle. You might prefer this written as a over 1 minus x. I would much prefer that. And then we know that when x equals a half, y is equal to 6. And so 6 is equal to a over 1 minus a half, and so a is equal to 3. And so y is equal to 3 over 1 minus x. You could substitute in at this stage, but you're going to have to sort of combine your logarithms together and unpick it all to get to c, and then do all that work again. So it's kind of easier to substitute in at the end. So I'll pop another set of questions on OneDrive for you to work through.